Okay, example number 4. Calculations with degrees, minutes, and seconds. So what we want to do here is we're going to add this up as if we were lining up proper decimal places. So we'll take the second number. Doesn't matter if you want to take, when adding, doesn't matter if you want to take the first and put it under second. Whichever you prefer is fine, because again, we all know that you can add in any order. And what I would do is once you have them all lined up, the degrees, the minutes, and the seconds, just add up the numbers. So 56 plus 46, that's going to be my 102. 35 plus 52 will be my 87. 28 plus 63 will be 91. Well, we know these numbers are too big because we have gone past 60 minutes. 60 minutes or more can never be in your answer. It's not a proper answer. It's not simplified, if you will. So we'll take our answer, and I space things out here just a little bit. And the one thing that you're going to notice is that whenever you add 2 degrees, minutes, and seconds angles, you're never going to be adding or carrying over more than 1 to the next location. These two values are less than 60. You won't have 2 60 seconds or 120 seconds to deal with. So we're just going to always subtract 60. If I do that, that'll give me 42 seconds. Well, we know that 60 seconds is 1 minute, so we add that over to the next column. All right, we're going to subtract 60 minutes, so 1 plus 87 is 88, minus 60, that'll give me 28 minutes. Add 1 over, 1 degree over. 1 plus 91 is 92, so that is my final answer of 92 degrees, 28 minutes, and 42 seconds. All right, part B, 180 degrees minus 43 degrees, 32 minutes, 16 seconds. Well, we have no minutes or seconds in the 180, so we got to break that down. Take away a degree, make it 179 degrees, and turn your 1 degree into 1 minute. Take 1 minute away from 60 and turn it into 60 seconds. So we're going to change 180 degrees to 179 degrees, 59 minutes, 60 seconds. So whenever you need to borrow a degree, you'll always end up with these two values once you subtract off a degree. So we'll replace the 180 with our new value, line up our minus 43 degrees, minus the 32 minutes, minus the 16 seconds, and we subtract. So 60 minus 16, 44 seconds. 59 minus 32 gives me 27 minutes. 179 minus 43 gives me 136 degrees. So there's my final answer. Now, again, you have to show the work to justify these answers. But if we want to make sure all your work is correct, there's nothing wrong with using your calculator to verify everything. Now, one thing that I would not recommend doing, because it's going to slow you down, is typing this in like we did in the previous video, typing in the degrees, the minutes, and the seconds like I showed you how to do that. It's just way too many different button pushings. To me, that's a waste of time. So the way I would type this in is I'm going to use my store button to store these answers as angles in decimal format. So for example, I'm going to take 28 plus 35, divide that by 60, just like we did earlier in the previous video, plus the 56 divided by the 60 squared. That's that 3,600. And then I'm going to use the store button right here. I'm going to store it into alpha A. All 26 letters are on this calculator. You can store anything into any calculator you want. Then I'm going to do the same for the second one. 63 plus 52 divided by 60 plus 46 divided by 60 squared. There it is. Store that in alpha B. So there's my two angles. Now, to add them together, you just have to hit alpha A plus alpha B. And now we want degrees, minutes, and seconds, go second angle, number 4, and it converts it into that 92 degrees, 28 minutes, 42 seconds, just like the answer we had here. Okay, now, with the subtraction, a lot of people make the following error. 180 minus 43 plus 32 divided by your 60 plus 16 divided by your 60 squared. Hopefully you can see why this is going to be wrong. You're only subtracting 43 from a 160, but then you're adding these two parts onto our answer. So if you wanted to enter this, then if you don't want to store, you're going to have to put all that in parentheses. So to do that with it already typed in, with the cursor on the 4, you can hit second, the delete key. Notice the flashing rectangle goes to an underscore. That will insert the parentheses and push everything over to the right. And then I'll go to the end, close my parentheses, second angle, add on number 4, return my answer in DMS format, and there's my 136 degrees, 27 minutes, 44 seconds. So again, a lot of calculator can be used to grade and check your answers, and I encourage that. Just don't use it to find your answer. I am going to be grading your work. Standard position, an angle in standard position is if the vertex is at the origin of the XY coordinate plane, the initial side is lying on the positive x-axis, and your terminal side is in either quadrant 1, 2, 3, or 4. Doesn't matter where it's at. Okay? So again, remember, quadrant 1 is from 0 to 90, quadrant 2 is 90 to 180, quadrant 3 is 180 to 270, 270 to 360 is quadrant 4. Now, angles in standard position whose terminal side will hit the x or y axis has angle values of 90, 180, 270, or 360, or 0. It could be either one here because they're the same. These are called quadrantal angles because now your initial side and your terminal side are on the x and the y axis, or all x axis, whichever one, separating out the quadrant. Remember from algebra, if a point is on, say, the positive y-axis, right here at 3, that point is not in quadrant 1 and it's not in quadrant 2. It's in neither quadrant. It's on the y-axis. Coterminal angles. Again, we have the terminal side. This is what we're talking about. A complete rotation of a ray results in an angle of measuring 360 degrees. By counting the rotation, angles of measures greater than 360 can be produced. Such angles are called coterminals, which means the terminal side of these two possible angles are in the same location. So for example here's my 60 degree angle. It's in quadrant 1. That's this arc right here. But if I were to add 360 degrees to 60, one complete revolution takes me to 420 degrees, putting that terminal side in the exact same location as the 60 degree. So those are called coterminal angles. You can also subtract 360. So if we took the 60 minus 360, that would be a negative 300 degrees going in a clockwise direction, and that would give us another coterminal angle. So these angles can be negative or positive. Here, the second example, we had 110 degrees. Now it made 2 revolutions and then the additional 110 degrees. So that's 110 plus 720 degrees, 360 plus 360 to give us 830 degrees. So those measures of coterminal angles always differ by a multiple of 360 degrees. Example 5, finding the measures of coterminal angles. I'll be perfectly honest with you, this is a little calculator work for me. Find the angles of least positive measure. So what you might want to do in the notes right here is put down your answer has to be between 0 and 360 degrees. They want it to be 0 degrees to less than 360. Everything inside of 1 revolution up to 360, because again, technically, 360 degrees is the exact same as 0 degrees. So if I had 1,106 degrees, I just start subtracting 360 degrees. Go grab your calculator. 746 minus another 360, 386. Minus another 360, 26 degrees. That would be my least positive measure for a coterminal angle. If I subtract 360 to that, now I'm coming up with negative values. If I start with a negative angle, then we add 360. Negative 150 degrees plus 360 degrees is 210 degrees. Okay, I'm somewhere between 0 and 360. Stop. Negative 603 degrees, add 360, puts me at negative 243. Add another 360, puts me at 117 degrees. Between 0 and 360, we stop. Now, applications of these problems, if you will, analyzing the revolutions of a wheel. Let's say a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? Whoa, so we're going to have to do some unit conversions here. So start with your first ratio, 270 revolutions per over 1 minute. So the first thing I notice is, wait a minute, we had to have how much in 5 seconds. So I need to change my minutes to seconds. So I'm going to multiply this by 1 minute over 60 seconds. I need to introduce seconds here. And the next thing is they want degrees, not revolutions. Well, every revolution is 360 degrees. So I'm going to multiply this by 360 degrees over 1 revolution. Now, how do I know which way to write the fraction? Is my goal is to cancel units. So I chose to put 1 minute over 60 seconds because I have minutes in the denominator. So I need, in this fraction, minutes in the numerator. That way they cancel. How did I know to put 360 degrees over 1 revolution? I need to cancel revolutions that were up in the numerator. They cancel. So now I can multiply this all out. 270 times 360 divided by 60, or if you wanted to, 60 can go into 360 6 times and multiply that by 270. That's going to give me 1,620 degrees per 1 second. Okay, now they just wanted my answer in degrees for 5 seconds. Okay, so we need to take this answer and do one more change. We got to multiply it by 5 seconds, and now seconds and seconds cancel. 5 times 1,620 gives me 8,100 degrees. And that wraps up our section 1.1.